Welcome, everyone. Welcome to today's talk lunch session. We're talking about tips and tricks for scrubbing source code for common coding mistakes using FxCop and PREfast, which originated as standalone tools, but today have evolved to form the respective managed and unmanaged code analysis components of Visual Studio 2005. And today's talk, we're going to take an interactive look at both technologies and how they can help to identify coding mistakes in the development process. So the first natural question that arises is why code analysis? Why should I use code analysis tools as part of my development process? And basically, you can think of code analysis as one more tool in your collection of strategies towards improving your overall code quality for your project. And what I think is the defining characteristic and probably the most beneficial characteristic of code analysis is the basic fact that for the set of issues that it can identify, it identifies them about as soon as possible in the development cycle. And effectively, the sooner you find an issue, and the cheaper it will be to fix that issue and address that issue in the long run. And so this will be kind of a theme as we go through the demonstration and look at the analysis. I'm going to come back and touch upon how some of the issues that we're looking at, how they really fit into this the characteristic of finding problems early in the development cycle. So before I start with the demonstration, let me just give a brief summary of the code analysis features that you'll find in the box with Visual Studio Team System in the upcoming release. There's code analysis for managed code, which is also codenamed FxCop. Supports all of the managed languages with the exception of J#, and also supports ASP.NET web pages. It's a binary-based analysis, which is what affords the multi-language support. As opposed, on the other hand, we have unmanaged code analysis in Visual Studio 2005 for C and C++. And it's a source-based analysis, which gives the added advantage that there are particular kinds of analyses which can only be done if you have access to the actual source code rather than the binary. The next interesting thing I want to mention about Visual Studio is the ability to automatically add in-source suppression for the managed analysis, basically as a right-click action in your list of analyses. It'll automatically add that for you. You can also integration with Team Foundation Server, and you have the ability to file bugs based on analysis results and get them into the work item tracking system. Maybe you can't fix them right away. And finally, you have the ability to enforce a policy which basically sets which analysis you want developers to run prior to check-in. And you can actually enforce that policy if you're using the team server source control system. Then you have the ability to sort of enforce a certain subset of the analysis as sort of required prior to check-in. So what are the types of defects that we could possibly find using code analysis? For example, for source code analysis, at least in the native case, you can find some issues which are bordering on typographical. Maybe there's a precedence error, and maybe it's not quite the developer's intent, and we might be able to flag that. A very common theme in code analysis is trying to identify misuse of particular common API. Security is a very big issue. I mean, and it really falls nicely into what I was talking about earlier, in that the earlier you identify a security issue, it's certainly cheaper, and there's that risk of shipping the software and then finding a security issue. Whereas for the set of security issues that the analysis is able to find, you get the benefit of finding them early. API design guidelines and best practices. If you're familiar at all with the .NET framework design guidelines for reusable libraries, FxCop, or the managed code analysis in Visual Studio, actually has its origin in enforcing those guidelines. So in addition to sort of correctness checks and security checks, we're also doing things like analyzing the naming conventions that are used in the code, and so on. There are also some rules around maintainability. One example, we can detect an overly complex method and suggest maybe a refactoring. And there are some performance rules with this that we can, based on very fixed patterns that are known to have more performant alternatives. If we can statically identify them, there are some rules that will do that. So with that, I think we're ready to dive right in and take a look at the demonstration. So we'll start by looking at some managed code and some analysis thereon. So the first example is a very common security issue when working with SQL. And here we have just a very basic routine, which is trying to retrieve the account number for a given username and password from a SQL database. And it turns out that there's a security flaw in this code. So I'll switch over to my demonstration machine, launch Visual Studio. And first, just to motivate the analysis, I'm going to actually launch this website. So for the purpose of illustration, this password text won't be hidden because what I'm going to type into it is going to be interesting in itself. And so first of all, let's say we were just trying to log in with any random password. For example, the system is telling us, we can't get your account number, your access is denied. But of course, I know what the query is, and I happen to know that there's a vulnerability that if I can just pad that password field with some extra SQL, I'm effectively into the system. I've now got the account number for the Nick user, and in fact, this magical password will work for any user. And this is something that if I had run code analysis on my website prior to deploying it, it could have identified for me. So I'll just go ahead and do that. All right, so here we go. It's identified that there's a query string with, if you can see, there are sort of two holes in the string, and it's basically asking you if those holes come from user input and possibly contain SQL code within them, you may be subject to this form of attack. And of course, we just saw this particular code is absolutely subject to the attack. So what you can do, you get your warnings in the error list as though they were compiler warnings, for example, and just double click to jump to source. And it'll take you to the place where the issue was found. And so for this issue, actually, the fix is always to use parameterized queries. So just go ahead and do that. So I'm going to add two parameters to my query, one for the username, and I'll take that from the username argument. And then I'll do the same for the password. And then, rather than doing this dangerous string insertion, I can actually just reference the parameters in my parameterized query. Thank you. We rebuild. Built successfully. Now I can rerun the code analysis. All right, no errors in my error list. Looks like I'm good to go. Let's double check. Let's go back to the website in the browser. go ahead and try that same trick. And we've closed the security hole that was identified by the code analysis. Just let me close this. So that's the issue. Just to summarize here on the slide, that's the text that's malicious, and there's lots of different ways that your app can get into trouble if you don't use parameterized queries, and that's something that we can identify with static analysis. So let's move on to the second managed example. And this is actually it represents a large subset of the managed code analysis in terms of enforcing the guidelines for reusable class libraries. And in this case, we have some of the most basic guidelines illustrated in this one tiny sample class. All the public fields should be properties. The casing is incorrect. The class name should be uppercase. The field names should be properties and then uppercased. And there shouldn't be any underscores. The same thing with the public method there. It should, in addition to not needing underscores, it should be cased with a capital P. Now, we can go ahead and run the analysis on this. And if we just grab this box class that I showed you on the slide, just grab it up in Visual Studio, and go ahead and run code analysis on that project. It's identified all of the issues that I found. And what I want here is to give a tip to everyone, which is it's actually can be quite challenging if you're taking a large code base that hasn't been run through this sort of this tool before for compliance against these naming guidelines. Renaming lots of code can be quite a challenge, but there's actually a great feature with Visual Studio 2005 for C# developers, which will allow you to actually safely rename items, and it will actually update all of the references in the project appropriately. So in this case, I need to rename the box class to start with a capital B. So rather than search and replace, I'll right-click on it and say refactor and then rename. And I'll change it to box with a capital B. I'll leave this preview reference changes on because it's kind of cool, and it's showing me that, in fact, to rename this successfully, I also need to rename the constructor. So I hit apply, and that's renamed, so that's cool. Another problem, I've got these public fields. They're supposed to be properties, so I can also use a cool refactoring technique here to basically encapsulate the field into a property. And that's the right name, actually. It needs to be uppercased once it's public. So go ahead and refactor that, and there you go. It's got the getter and setter, just as it should be, and I can just quickly do the same thing with the width property. And then finally, this lonely method needs to be renamed so that it conforms with the guidelines. And that would be just like that, print to console. And there's one call to it, which I happen to slip into the constructor just for the example, and that needs to be renamed, and the refactoring takes care of that. And then when I save, build, make sure everything's all right, go back, run the code analysis, and I should be okay. Yep. Got no warnings. Just close this. All right. So just so for reference, those were the issues with public fields, casing, and underscores. And the takeaway for naming and design is to use the refactoring to resolve the issues. There's also another rule which I didn't show, which works nicely with refactoring, which is around hitting a certain threshold of complexity in your code based on the control flow graph and the cyclomatic complexity. And you have an option to take a chunk of code in Visual Studio 2005 and refactor it out as a separate method. So you could also fix that maintainability issue with this as well. So Just thought I'd mention that. Let's move on to the next managed example. Now, this is just a piece of a small sample app which keeps the user's preference for a font in an XML file persisted to disk, so that the next time you launch the application, he comes back up and you've got the same font that the user had specified the last time that it run. And it turns out, simple though this code is, there's a bug, and it's something that static analysis can find. So let's go back to the demonstration here and take a look at this code in Visual Studio. So actually, I'll just motivate this, and I'll show you this little sample application. Actually just prints hello world based on the font of the user's choice. So if I launch it, I'll pick this cursive font at size 14 and say OK. And there it is. Hello world, cursive size 14. I can close it. Now it will no longer prompt me for the font. It's remembered that that's what I want. So it seems like this is working, but there's kind of a little trick I can play on this application and go into the control panel and change my regional and language options. And rather than English, I think, why not I'm shipping this Hello World sample maybe to German customers, so maybe I want to check that out. And next time I launch the application, something's gone wrong, and it doesn't look like 14. I'm not sure exactly what's going on. Let's take a look at the XML file that this application is reading. It turns out that the precision in that form when you're selecting the font is actually a floating point value, and 14 was just rounded. It turns out that it's 13.8 actually, and it also turns out that in the German locale, the dot is actually just represents the digit grouping, just like the comma does in the United States. And so the parser in .NET defaults to the current locale, and every time it encounters a dot, it ignores it, saying this is just grouping digits. And so it's now determined that this application has the font size of 138 rather than 13.8, which is a bug. So let's see what code analysis has to say about it. Just run code analysis in that project. So it's found two places where the I-format provider argument has not been passed. And interestingly enough, of course, there are two places. One place where the settings file is saved out. We need to save it with some sort of invariant, with the invariant culture, so that we can say, always, no matter, regardless of the current user locale, the format shall be invariant. And also when we read it back in. So that's basically to fix that. We have the size being converted to a string here, and that takes the I-format provider. So when you're persisting data, which is not intended to, it's not intended to be displayed, it's actually the core data for the application needs to be kind of invariant across cultures. That's exactly the time when you need to pass invariant culture, and unfortunately, just about every method in .NET gives you current culture as a default, so there's really no way around it. Every API that you find that takes an I-format provider argument, you really have to look at each call site and ask yourself, is this something I'm just displaying to the user, or is this something that I'm actually persisting and it's important? And so basically what the code analysis will do, it will actually ask you to specify an I-format provider, even if the default value of current culture is okay for this particular use. We basically enforce the developer discipline of specifying that the default is in fact intended. And so that way we can just simply do the analysis by determining that the argument hasn't been passed. And now I'll just jump over to the second error. So this is where we're actually parsing the size, and we want to parse using the invariant culture as well. And I'll just rebuild. And my font size is back, so we'll follow up with the question afterwards, but yes. Okay, just close this off and we'll move right along to the next example. So first I'll just summarize the missing argument that's defaults to current culture. So there's a set of rules in the managed analysis around getting serialization right, and it lends itself well to code analysis because there are subtle mistakes you can make that can cause your types not to serialize as you might have expected. Here we have just a run-of-the-mill exception, and it turns out that there's a serialization bug in even this small code. So let's move back to Visual Studio, open that up in the IDE, and take a look. So here's the exception, and right underneath it is a very simple program, albeit contrived, that's actually throwing sample exception from a separate app domain. And then in the parent app domain, we're just trying to catch it and display the message. In this case, the sample exceptions message is hello world. So if this application did everything right in a very roundabout way, it would print hello world. However, there's a problem with this code. So if I just go ahead and set it as my startup project and debug it, let's see what happens at runtime. Okay, there's an unhandled exception. Wait, I thought I was going to catch the sample exception, but no, I've got a serialization exception. And so I won't be able to catch the serialization exception. I don't have a handler for that. I really do want the exception to propagate back to the parent app domain with the hello world message. And while this exception text is quite clear as to what the problem is, it's telling you that the exception type needs to be marked as serializable. The main problem is that this is a runtime error. And you can imagine in a real application, you know, the paths through which you're throwing an exception or may not have app domain interaction or might be serializing for another reason could be not necessarily provoked by your test coverage. So while the runtime error is very clear, you could imagine shipping this bug in one form or another, and that's why static analysis can really help with these sorts of issues to get the code fixed as soon as possible. So I'm going to go ahead and see what the analysis has to say about this project. Oops. Sorry about that. It's the wrong project. Sorry. Give me a second. Well, thankfully, the other project is already clean, so running code analysis on it wasn't too bad. So, all right, now we can run code analysis on the intended project. Looking for, see if we can find the root cause of this bug. So there's actually two serialization bugs. Of course, because my application came down as it hit the first runtime error, I never got to see the second one. So there are actually two problems. The first thing is that the exception should be marked serializable because it's iserializable, and so all exceptions, the root exception is serializable, and you imagine that all subclasses are basically inheriting this contract that they're serializable because it doesn't have to be an exception. It could be any class whose parent class is serializable. The subclass could be sitting in some field typed as the parent class, and the sort of attempt to serialize it will then be expected to work based on the basic object-oriented principle that the subclass can replace its parent class. And so that's basically how this analysis is able to determine this problem which turns out to be even more severe with exceptions if you have any cross-app domain throws. So it's just asking me to mark this type as serializable. So I'll go ahead and do that. And if I were to run this again, I'd hit the second error, which is that for iserializable types, there needs to be a special constructor which can deserialize the type effectively. In this case, we don't have any of our own instance data. Just pass on those incoming parameters that the serialization subsystem call us with and just pass them back to the base class, and it will have the storage for the message and the inner exception and deserialize those correctly for us. So just build and go ahead, run code analysis one more time just to make sure it doesn't find the error. It hasn't. Now we can run this. And there it goes. It's now working as the developer intended. Right. So the issue, missing serializable attribute. Got to put those on all the iserializable types. You're missing the deserialization constructor, same thing. And in the case of exceptions, you can't throw them across app domains if they can't be serialized. So we're going to shift gears a little bit and look at some of the unmanaged code analysis in Visual Studio Team System. And so let's jump right in. Let's take a look at the first unmanaged example. So this is a pretty unassuming piece of code. It's trying to do something fairly simple. It's just allocating a buffer, getting the module, the file name for the current module, and printing it to the console. And there's actually a buffer overrun in this code. And we can use the unmanaged code analysis components in Visual Studio to find it. So let's switch over here. Just in this unmanaged project, I've actually enabled code analysis as part of the build, which you can do with both unmanaged and managed code. And then you get the feedback immediately upon every build. And in this case, the feedback that we're receiving is that there's a buffer overrun. And more specifically, it's telling us that the buffer overrun is due to the mismatch between the number of characters and the number of bytes that are expected by API that are interacting with one another here. And so it turns out that here we've said the max path is the maximum number of characters, but we pass it to malloc, which takes a number of bytes, and so we actually allocate a buffer that's half the size it should be because we're using Unicode characters here. And so that's basically, I mean, the fix here would simply be to allocate the buffer that was large enough, but and then we wouldn't have that mismatch. But there's actually a second error that's come up that's not directly related to the buffer overrun that I intended to demonstrate with this example, but I thought it was interesting enough to leave the bug in this code because it's not something that's necessarily obvious. It's actually determined that the call to get module file name does not respect the contract for get module name because this parameter might be null. Now, the reason it knows that that parameter might be null is because it also has a piece of information that malloc might have returned null in the case that it was out of memory. And so there are actually annotations sitting on these library functions describing their contracts. First of all, the fact that malloc may return null, and second of all, the fact that get module file name cannot take a null buffer argument. And so the interaction between these API actually is within this method is actually picked up by the unmanaged analysis. I'm not going to cover it in this talk, but it's actually possible to annotate your code similarly to the library code and to get this extended analysis, this sort of precondition, post-condition violation based on interaction between API. So I just thought I'd point that out, but we'll move on to the next native example. So just to summarize, right? character and byte counts, misuse of API. All right, very simple example. Unassuming piece of code. Just take one integer, shift it by the other, return it in a, take two 32-bit integers and return it in a 64-bit integer. Now, this is the kind of mistake that most developers, if they look at it, they'll probably figure out what's going on, but it's maybe not immediately obvious, and what's actually happens here is that the shift occurs before it's coerced to 64-bit, and so you actually overflow your shift and then return it, and you actually wouldn't want to do that. So just to show that, we can take a look at something as simple as that and just rebuild. Take a look in our error list, and it'll find these sorts of errors. Let's move right along. Next unmanaged example. So we just need to make sure, in this case, the fix would be to cast the X value before shifting it, and then that would have caused the shift to occur in a 64-bit space, and we'd be fine. So let's look at third unmanaged example. A very common mistake that programmers make working with API that return H result is to sort of imagine that H results have the same, very similar semantics maybe to a Boolean. We know that a 0 H result is SOK, and that, so we could imagine, okay, maybe false, is kind of in a Boolean context, an H result that's false is a success, an H result that's true is a failure, but that's not actually true. There's actually a set of success codes, a set of error codes. So in this case, we would actually, the unmanaged code would actually pick this up, and the fix here would simply be to call the failed macro right here to actually get into this branch if this is a failure code. And this example is sufficiently small. I'm not going to bother to jump over to the IDE. I think that's basically simple enough. But these kinds of mistakes can be found when working with H results. Fourth example, also very simple but very common, misuse of printf, specifically API that take these printf-like format arguments. We often have problems like type mismatches in the arguments, like in the first case, or too few arguments, too many arguments. Maybe you missed a format specifier. Maybe you just passed an additional argument, and the analysis will pick this up. Now, this relates back to what I was saying originally, because you can imagine, that the printing or formatting is happening in a negative code path. Something's gone wrong. You're trying to log the fact that something's gone wrong, and that's the first time this code is hit, and there's a problem. So finding these kinds of mistakes as they're found through static analysis can really help in that regard. This one I do want to show in the IDE. It's rather contrived, but it's actually related to the first example. We have this piece of code which is going to have a pointer to an integer, and based on some condition, it's either going to assign the address of one of the local variables to that pointer. Otherwise, it's going to allocate some new memory and point to that. And in either case, it's going to dereference that pointer and store 27. Now, related to what I said earlier about malloc in the first example, the analysis is aware that in one of the code paths, it's possible for the pointer to be null, and so dereferencing it would be an error. But this is a simple example, but what's most cool about this example is actually, if we go ahead and analyze it in the IDE, and then we find the corresponding error right here, double click, it actually highlights the path under which this could happen. So you enter do work, and then this condition, and then it tells you this branch is basically not taken, or we go into the else block here, and then we assign to the pointer, which can be null based on this highlighted path. And so you can imagine, more real-world scenarios, you can actually have some pretty complicated paths through which something may or may not be null, and the analysis will actually show you why it thinks, in fact, it can be null. So that's it, just as I said, but the big tip, use the path highlighting to try to discern what's going on and really understand, can be really helpful. So that's all the demonstration that I have for today, but I wanted to talk about where you could find out more information. We got a hands-on lab running throughout this week. Based on, you can use these features. You can interact with projects that are basically the projects that I demonstrated right here. So you can take a look at it for yourself and play around with it. Look at some of the more broad usage of the tool, how to turn rules on and off, how to suppress warnings. And also, we are also going to be in the track lounge, the tools and languages track lounge. So if you have any specific questions, you can either ask me right now or find me at the track lounge. But this is part of Visual Studio. Everything I demonstrated today is based on bits that are going to ship in November with the Visual Studio 2005. So, and it's all in beta 2 as well. And I also want to mention, please check out the public forums. There's one for FxCop. There's one for Visual Studio Team System, and you can ask us any questions over there if maybe after the conference you had some more questions. And I just finally wanted to point out that FxCop, the managed component, is also available as a standalone tool that you invoke kind of separately, targeted against the managed binary, and get some analysis results. You don't get the benefit of the VS integration, but if you're maybe still using VS 2003 or maybe for one reason or another, you can check out the standalone tool as well. Well, that's it. Wondering if there's any questions? Yeah, so the question was, is there an FxCop rule that detects complexity? There is. It's not part of the free tool. It's actually part of Visual Studio integration only, and it basically sets a threshold of 25 on the complexity and fires a warning if it exceeds 25. And you can opt in and out of that rule, but that's how it works. Part of Team Developer and Team Suite, so not part of the professional SKU or Express SKUs. So the question is it possible to extend the tools? I suppose you're asking, is it possible to write new analysis? Right. So for the managed code analysis, it is possible to extend the analysis, and for the unmanaged code, it isn't at the moment. Yes. Yes. There's actually an option in the. So the question was, is it possible to integrate this into the build system? So you can actually just enable it as part of your local build. There's also an option if you're using team build to enable code analysis as part of your nightly build, and also, with check-in policies, so you kind of have it through the full spectrum of the team development environment. You're running it locally with every build. You're enforced that you run it before check-in. The team build is going to run it. So yeah, it's with the team suite, you get that. Yes, it is integrated with the build. Yeah, I think you asked one already. Somebody else. Yes.
Are the XML schemas identical between the standalone tool and the integrated tool for the output file?
Yes, they are. Any other questions? Yes. Yes, the C++ is basically only available with Team System. That's correct. Yes.
Does FxCop, does it contain the same rules that StyleCop used to contain?
No. So StyleCop is a completely separate effort based on looking for style issues. And as I mentioned earlier, FxCop actually works off of a binary MSIL code. And so most questions of style actually cannot be, at least as with respect to formatting, cannot be determined from the IL. What we can do, the closest analysis to that we have is basically naming conventions, et cetera. But even then, we're only looking at publicly exposed API. So if you have a private field, there's no naming rules, there's no style enforced for that. But if you,
what did happen to StyleCop then? Is that just an internal Microsoft tool?
I don't know.
Okay.
But if you come grab me after the show, we can talk about it. Any other questions? Yep. You have to distribute it to all the clients. So the question was, if you have your own custom rule, do you need to distribute it? With the version that will be available soon, you will have to come up with a mechanism for distributing it. We will, in the final version, have a mechanism for detecting if the version numbers are out of sync. So if you have the best practice of reversioning your rules as you make changes, you can actually get the system to at least detect if there's a client in a bad state, but you do have to take ownership of distributing them. Right? Yes. Uh-huh. Yes. Yes. It would be possible to write rules that analyze, but a C++ CLI assembly could be mixed mode. So if the code is compiled, so if the individual file within the code is compiled with /CLR, thereby generating managed code, then your analysis would pick that up. Absolutely. Yes. Yes. Yes, you can. Any other? I guess it's getting close to done, but if you want to follow up with me in person, I can take some more questions. Thanks.